Hello again. On this video, I'm sharing some tips for the homework for section 3.5. And in section 3.5, there's lots of things going on because this deals with rational functions. And so these are the kind of functions that have what they call asymptotes associated with them. So this next set of videos are going to cover a quick overview of the different kind of asymptotes and how you go about finding them, and then how you go about graphing a rational function using the asymptotes and the intercepts. Hopefully sharing some tips and some pointers on how to do these kind of questions in the section 3.5 homework. So the first thing to look at is the so-called vertical asymptotes. Vertical asymptotes are going to look like this right here, x equal a, because that's the equation of a vertical line that goes up and down through the number a. So in order to find the vertical asymptotes, we first factor the denominator, cancel any factors we might see in the fraction we're going to have. Once we've reduced it, simplified it, then we're going to set the denominator equal to 0 and solve for x. And this is going to tell us what the vertical asymptotes are. So I'm going to show you a few quick examples of this, starting with this first one here, where we have f of x equals x over x minus 3. In this case, we don't need to factor anything because there's nothing really to factor. So I'm going to take the denominator and just say x minus 3 equal to 0. And then solve for x. All that you have to do to solve for x is add 3 to both sides, and you have x equal to 3. And that is what we call the vertical asymptote. And I might abbreviate that VA just to make it easier to write. So the vertical asymptote is x equal to 3. On this next example, where we have g of x, okay, we have this one, x plus 3 over x squared minus 9. So what should we do first? By what I mentioned before, we first should probably try to factor the denominator, since it looks like there's something a little bit more than we had in the last example. So if you want to take just a second to look at it and see if you can tell, how do you factor that denominator? It's a difference of squares, and we could factor this as x minus 3 times x plus 3. Okay, and since we did it that way, now we notice there's an x plus 3 on top and an x plus 3 on the bottom. That will actually fully cancel. Though we still have something on top, just the number 1, since the numerator canceled and divided down to just being 1. So this function is simplified to be 1 over x minus 3. Okay, actually that's similar to what we just did, right? But now that it's simplified, we can set the denominator equal to 0, and if we solve it, we get x equal to 3. And that's what they call the vertical asymptote. Okay, and so in this situation, this is all you'd have to do if you just needed to find the vertical asymptotes. The homework, however, might ask a slight little bit a piece more of information. It might mention something about holes. Okay, so just as a side note here, if it does mention holes, for instance, what you're going to need to do is take that thing that you canceled. So you canceled an x plus 3 from up above. Take that thing and set it equal to 0. So the x plus 3, if you set that equal to 0 and solve for x, you get x equal to minus 3. Okay? So that's just a little bit of an extra thing that you might notice on the homework. But again, to find the vertical asymptotes, the most important thing to understand from this section, that is going to come from exclusively from setting the denominator equal to 0. So just keep that part in mind for the most part. If it asks you about holes, then what it's asking you to do is take that piece that you crossed out from up above, go to the side, set it equal to 0, and then solve that part for x. But first, again, do the denominator so you can get the vertical asymptotes. And really only worry about the holes. And I make note of it here just in case it does ask you. And you can make note of that and work on that part if it does, for instance, ask you how to do that. Okay, so hopefully that made okay sense. There's another example here for vertical asymptotes, here h of x. And go ahead and look at it for just a second and think about what you could start with if you're asked to find the vertical asymptotes here, based on what we've done so far. All right, well, you can't actually factor this, though it seems to look like you might. This thing in the denominator can't be factored because it's not a difference of squares. It has a plus instead of a minus. And so we're not going to be able to factor it, but we can try to set it equal to 0 and try to solve for the vertical asymptotes. So to do that, now we have it set to 0, subtract 1 from both sides, x squared equals -1. To solve this equation, we have to take the square root of both sides with a plus or minus square root. So what we're going to get is x is equal to plus or minus square root -1. But that's not really actually going to solve too well for us in this case. This kind of square root of a -1 gives us no real solution. And that's because it's a square root of a negative number, and we can't find a real number that'll solve it for us. These situations go into something called imaginary numbers, which we don't have to worry about in this section. So if you ever see the square root of a negative number here, what it's telling you is that there's no vertical asymptotes to solve for. So these are the situations we might run into. We might have a single vertical asymptote. You may have to cancel, reduce, set the denominator to 0, find the vertical asymptote, or you might find that you can't solve it and there's no vertical asymptote to solve for.